Hi everyone. So this is going to be the first video out of 4 videos that are going to be focusing on just factoring. The first video is going to consist of this flow chart that I have in front of me. Then we're going to look at what to look for in order for us to be successful at factoring. And then we're going to learn how to actually factor out GCF from a problem. Then the next video is going to consist of factoring out squares and cubes. Then the third video is going to consist of factoring things that have 3 terms, and then the last one is going to be by factoring by grouping. So in the first video, we want to first understand this flowchart and understand how the process of factoring works out. The first thing that you want to look at whenever you have to factor out an equation is there a GCF? Because if there's a GCF in your problem, you have to factor that out. You always have to begin by factoring out the GCF because it's going to make your life a little bit easier. Now, sometimes there's a GCF and you're going to factor it out, but sometimes there isn't, and that's fine. So the next question after you ask yourself, is there a GCF, is, well, how many terms are in the actual equation or in the polynomial? When you ask yourself how many terms, this is the most important question when it comes to factoring. Because when you have to factor, you're only going to have 3 possibilities. Now you may have more possibilities when you get later on into math, but in the beginning of factoring there's only going to be 2 terms, 3 terms, or 4 terms. Now when there's 2 terms, the only way that we can factor out 2 terms is either your equation is a square or a cube. So what I want you to memorize is, when you take out your GCF if there's 1, and you ask yourself how many terms are in the equation, and you say that there's 2 terms, you could only factor out if it's a square or a cube. That is the only time you're ever able to factor out. Now you're going to notice that for sum of squares there's actually no equation. So whenever you have a sum of squares, it's going to be prime, but we'll get to that when we actually work on that video. So you're going to ask yourself, well, how many terms are in there? Sometimes 2. You're going to ask yourself, well, how many terms are there? Sometimes there's 3. And if there's 3 terms, the only way that we could actually factor out is by trial and error, by creating the 2 parentheses and figure out numbers that go inside of that. Then lastly, if there's ever 4 terms, the only way that you could factor this out is by factor by grouping. Okay? This is the most important question. How many terms are in your equation? Because I want you to memorize that if there's 2 terms, it's either a square or a cube. If there's 3 terms, factor by trial and error. And if there's 4 terms, factor by grouping. That's going to happen every single time. Okay? Now, after you're done factoring, you're going to ask yourself at the end, well, can I simplify this a little bit more? Is each factor in the simplest form? Because if it's not, if you can factor a little bit more, you're going to keep on going to the beginning and work the way through all again. Now, in the case that you're done, well, I don't really want you to check by multiplication. I want you to believe in your work. I want you to trust in yourself. Because factoring is just a long process. So if you're able to ask yourself, can I take out a GCF? How many terms are in there? Which one does it lead me to? You're going to be fine. Okay, so the next part of this video is going to be just counting the number of terms. So that's going to lead us to here. Well, in order to factor out, remember, you have to be able to count the number of terms in your equation because that's the most important question. So in the first one I have x squared minus 9. Well, that is 1 term and then 2 terms. So because it's 2 terms, if I'm able to factor this out, that means it's either going to be a square or a cube. A square or a cube because there's 2 terms. Now, we're not actually going to factor this out. All we're trying to do is trying to figure out how many terms are in each polynomial. Now I'm going to look at my next one. X squared, 1 term, minus 4x, 2 terms, 12, 3 terms. Well, okay, that means there's 3 terms. So that means if I could factor this out, I have to factor it out by trial and error. There's no other way around this. I have to do that method. Now I'm going to come down to 27x cubed minus 8. Okay, 1 term, 2 terms. So because there's 2 terms, I'm not even going to look at 3 or 4 terms because this doesn't apply to this problem. I have to look at 2 terms, and the question now becomes, is it a square or is it a cube? Then the last one, 12x cubed minus 2x squared minus 30x minus 5. Now, if you'll notice, this is a bit longer. So then you're going to count the number of terms. 1, 2, 3, 4. So because there's 4 terms, that means the only way to factor this out is factor by grouping. That's why being able to count the number of terms is the most important question, because it's going to guarantee our success in factoring out polynomials. So the next thing we're going to work on is we're actually going to factor out GCF, because at the end of the day, GCF is the first step. You have to be able to factor out a GCF if there is one. Now sometimes there's always not going to be a GCF, and that's fine. So what we're going to do is we're going to look at this example, the first one, x cubed minus 4x squared. The steps in factoring out GCF is you want to take out a number that they have in common. So that's always the first thing you want to do, take out the number. Then the second step is take out a variable. So take out a number if they have it in common, or take out a variable. So I'm going to look at this first example, x cubed minus 4x squared. So I'm going to first look to see if they have any numbers. And what I mean by numbers is, do 1 and 4 have a GCF, a greatest common factor? I'm going to say no, because they don't have any numbers they have in common. So the next thing I'm going to look at is I'm going to look at the variables. Well, I know that they both have an x. So I'm going to take out an x. But the question becomes, well, x to what power? You always take out the variable that's the smallest. So 3, 2. So since the squared is the smallest, I'm going to put that there. Now my next step when it comes to factoring, I'm going to put x squared underneath that division symbol, this line. The reason I do that is because I have to figure out what I'm left with. Because when you take out a GCF, you have to figure out what's left. So what I do is I put on the bottom and then I'll just divide. X cubed over x squared is going to give me just x. And the reason is you subtract your exponents. 3 minus 2 will give you x to the first power. Then ask yourself, well, minus 4 over 1 in imaginary 1 will just give me minus 4. But what about x squared over x squared? That ends up canceling out. So I'm just left with x minus 4 on the inside. And then this is how you factor out your GCF. Now we may be able to factor out a little bit more, but all we're doing now is just focusing on GCF. So let's look at the second example. 5x to the fourth plus 20x squared. Look to see if they have any numbers in common. If you'll notice, they do have a 5 in common. So I'm going to take out a 5. Then my next step is look at the variable. They have an x. But x to what power? Which one's the smallest? A 4 and a 2, so I know I can take out the squared. So my next step is to put underneath both terms. And I do that because it's going to help me figure out what goes in here. 5 over 5 is a 1. x4 over x squared. Remember, subtract the exponents. X squared. 20 over 5 will give me 4. X squared over x squared cancels out, so all I'm left with is 1x squared plus 4. Now remember, you don't have to write the 1. I'm only writing the 1 so I could show you that 5 over 5 gives you 1. Okay? So let's look at the next one. Look to see if the numbers are in common. 4 and 7. Any greatest common factor? Okay, so there's nothing. What about variables? X and an x. So they have an x in common, but x to what power? Which one's the smallest? There's an imaginary 1 right there. So 1 and 3, imaginary 1. Y squared, y? Well, they also have a y in common. Y to what power? This is a 2. Remember, this is an imaginary 1 as well. So just y to the first. So what I now have to do is I have to figure out what goes in the inside. So I'm going to put xy underneath. Then you're just going to divide. 4 over 1 will give me 4. x1 over x1 cancels out. Y squared over y will give me just y. Then work on the second half. 7 over imaginary 1 will just give me 7. X cubed over x, subtract them. 3 minus 1 will give us x squared. Y1 over y just gives me 7x squared. Okay? So if you're able to take out the GCF and put it underneath both terms, it's going to help you figure out what goes in the inside. Now lastly, we're going to look at this one. So it doesn't matter how many terms are in your polynomial. There's always could be a GCF, no matter if there's 2 terms, 3 terms, 4 terms, or etc. So I'm going to see, well, what can I take out of this equation? 15, 3, 12. Any numbers they have in common? Hopefully you saw 3. Then you're going to look at your variables. Well, x, x, and x. Okay, so I can take out an x. X to what power? Well, this is a 3, this is a 2, this is a imaginary 1, so that means I can take out an imaginary 1. So my next step is I want to figure out what goes in here. So to figure out what goes in here, I have to put 3x underneath all of the terms. And then divide. 15 over 3 will give me 5. X cubed over x to the first, subtract the exponents, 3 minus 1 will give me 2. So that gives me 5x squared. 3 over 3 will give me 1. X squared over x will give me just x, because remember, 2 minus imaginary 1 will give me x to the first. And the last one, 12 over 3 gives me 4. X over x cancels out, so I'm left with here. Now, can I maybe factor this out, or factor this out on the inside? Possibly, but all we're trying to focus on is the GCF. In order for you to be great at taking out the GCF, you have to understand that you always want to look at the numbers that they have in common first, the greatest common factor. Now after you figure out the number, well then work on the variable. And remember, variable is the smallest degree. Now after you find your GCF, put that under each term, because you want to figure out what goes in your parentheses. And then after, well then that's when we want to count the number of terms to see if, well, can I factor this out any other way? Okay? So when you're working on factoring, we have to remember, first question, is there a GCF? Because if there is, you have to factor out that GCF, which we just did. Then your next step is, well, even if there isn't a GCF, how many terms are in your equation? 2, 3, and 4. If you're able to memorize just the stuff that's highlighted, you're going to be fine.